Hello everyone, welcome back to Oracle Database Administration Workshop, and today we'll start with our first chapter, that is exploring Oracle Database Architecture. Okay, what is Oracle Database Server? And then I said people may call Oracle Database Instance, Oracle Database, and Oracle Database Server. Just to correlate all these terms, you have to be very familiar with these terms, so that going forward we use these terminologies many times. If I just correlate our normal day-to-day human life with our database, see, this is a human being here, human, and he has a pair of hands, and he has a small brain. And if somebody tells him something, to write, or somebody tells him something to remember, like what he say, he will try to keep the things in his mind. And after a certain time, he may forget that thing, so he will slowly start writing into the his own notes or notebook. And once eventually the people say all the things he used to keep it in his mind, and then start slowly writing into the notebook. And then once this notebook is full, and then he will take a one more notebook, and then he will start writing into the book, and then he will eventually end up with writing a deck of books, right? And over the period, if somebody and some other person comes back, and if we ask the same questions, or if we want that same information, and if he can remember that thing, and immediately he will respond back to that guy. And if he don't remember, what he will do, he will go back and he will search all his books, and he will retrieve that information, and he will give it back to that guy, right? So the same chronology, like it will happens in our database. What happens, we have a instance that is kind of our human being. Instance has a memory and some processes, kind of background process or foreground process, whatever process. Like this memory, this instance is equivalent to human, and this instance has a memory and process. This memory is equivalent to how this human has this memory, and Oracle instance also has this memory. And this process are nothing but how this human has a hands, which will help him to write into the notes. And some kind of, we have processes in the instance, and which will help to write whatever there in the memory to the actual storage files or actual data files. This storage or data files are nothing but like how the human maintains the books. Similarly, we will keep all our Oracle database data, actual business data, into storage files, that is called database. And then similarly, this, like how somebody asks later, some the time later down the time, if somebody asks for the information, this human will look into this file, this books, and then he will retrieve the data and then give it back to them. Similarly, if you query something, some data to this instance, this memory will look into data files and then retrieve the data and then give it back to that user. It is similarly how the human life works, and our database also works on the same way. Again, if you may ask, what is instance? Instance is nothing but memory plus the background process. Both combined together, we can call it as an instance. It is like our human being. And what is database? Database is nothing but our actual data storage. Either it may be a NAS or SAN or NFS or whatever it is. It is our actual data. Database is nothing but actual data resides in that. And this instance plus database together, we can call it as a Oracle database server, right? So if somebody asks what is Oracle database server, it is the instance plus database. If somebody asks what is database is our actual data storage. Either it may be a OS files, or our normal Linux OS storage, or the NAS or NFS or SAN or whatever storage. Actual our end user data or business data resides in that. What is instance? Instance is nothing but memory plus background process. So if you understood what is this Oracle database server, some of the questions, common questions you may arise: is there any limit to the number of data files? Is there any limit to the number of data files? No, absolutely there is no limit. You can have n number of data files. How this human is keeps on writing into the books, like Oracle also keeps on writing into the OS files or storage files, or the any database files, right? So there is no limit on that. Is there any limit to the size of the each data files? Like each data files, each book, each book will be having some limits, right? Some books will be very smaller, some books will be very larger. Similarly, in database also there is a limit for each data file, like 32 GB or 100 GB. Like there is a limit. You will get to know how that limit will be set. Of course, for answer for this question, there is a limit for each data file. And is there any limit for the size of database. Like size of database is nothing but like size of or sum of all the data files, sum of all the books, right? Is there any limit? No, absolutely there is no limit, because you are going n number of data files and you are keep on increasing your database, right? There is no limit on that. Okay, let's continue to the next topic. Okay, what is standalone versus rack? In our database, we will deal with two kinds of environment. One is standalone and other one is the rack. Standalone is nothing but a single instance database. If you see, this is Linux server A, you can see Linux server A, and I have instance 1 and instance 2. Instance 1 is pointing to database 1 and instance 2 is pointing to database 2. That is standalone. Any server or any application or any user connect to instance 1, he will access to database 1, and any user connect to instance 2, he will connect to database 2. There is no relationship between instance 1 and instance 2. These two are separate databases, right? So that is kind of standalone. If this server goes down, entire nobody can able to access my database. That is kind of standalone. And if you come to the rack, I have a database here, D stand for database, and I have instance 1, instance 2, and instance 3. Like this is server Linux server A, Linux server B, and Linux server C, whatever name it is. These are the Linux servers. And end users or application may connect to instance 1 or instance 2 and instance 3, and this all three instances are able to access to my database. If this instance 1 goes down, automatically the user can connect to instance 2 and then try to access my database. And if this instance 2 goes down, again user may connect to instance 3 and then able to access my database. It is kind of performance booster, because n number of user can connect to any of the instance and they can able to access database. Okay, so if that is about the rack and clusterware, like you may ask, right? Like, see, suppose this server A goes down, I may lose my entire database. And if this server goes down, I have another two more instances to connect to my database. That is the one of the highest, like, advantages of having our rack or clusterware. Rack is nothing but clustering or grouping together number of instances and making it as a single database. And standalone is like one-to-one mapping. It's a rack is like many to one mapping. Many instance can map to one database, and in standalone single instance can map to single database, like one-to-one mapping, right? If you understand about this standalone and rack, and few common questions you may ask: how many database server we can install on a server? As I said, like this is the Linux server here, and this is server A, and then I showed you here instance 1 and instance 2. Is there any limit? I can install only two instances. Of course, there is no limit on that, because if your server is having so much memory, like 10 GB, 20 GB, 100 GB, and 200 GB, whatever the memory you have, and you can install n number of instances on that. If suppose I have this server of 30 GB and I have an instance created with of 10 GB, I can install, eventually I can install three instances on that, right? Instance 1 10 GB, instance 2 10 GB, instance 3 10 GB, altogether 30 GB. Like it's all depends upon the how much memory and how much resource you have on this server. There is no limit. You can install a number of database as long as your server has enough memory or enough resource. Can I have an instance and database on a different server? You can see here instance on this server A, and database, can I have it on different server? Of course you can have it. As I said, this is going to be your remote storage, either going to be NAS or SAN or NFS or anything. You can have this database on the different server, or you can have on your physical LAN or on your mount point, physical mount point on this server. You can have this database on this locally or any remote machine. You can have that one. Answer to this question is yes. You can have both instance and database on different servers, and multiple database and single instance. If you see here, I have database 1 here, database 2 here. This is our dev database and this is our test database, or this is our QA database, or this is our UAT database. Multiple database can point to single instance? No, that is of course in your Oracle technology that is not possible. This database 1 is different and this database 2 is different. Both cannot be communicate in one instance, because if single user connect to instance 1, he will be able to connect to both the database if this is achievable. That is why in Oracle it is not achievable. So one instance can communicate to only one database. That instance cannot communicate to the second instance. And just to give the one more example for this is multiple database in single instance. This is supported in Microsoft SQL Server, whereas in Oracle this is not supported. In Microsoft SQL Server, like single instance, and they can spin off n number of databases. Like instance 1 can have database 1, database 2, database 3, database 4. In MS SQL this is possible, but whereas in Oracle this is not possible. Oracle, the reverse is possible, like multiple instance can talk to one database, and single instance cannot talk to many databases, right? So if that is clear, I'll just quickly go to the next, and that is our quiz session. The first quiz is: rack database cannot have more than 8 nodes. As you see here, I showed you number of instances, right? So how many nodes are nothing but your instances. Just guess your answer. Is this 8 node is a limitation in our rack, or can we go more than that? So just guess your answer here. And I'll just quickly cover some basic terminology before we get into the class. That is three-tier architecture. Three-tier architecture, as name indicates, it's the 3 layers of architecture. You can see management layer or data management layer. That is where your actual data resides. That is going to be your MS SQL or Oracle or MySQL or DB2, whatever database. It's the your end database storage. And business logic or middleware or Apache Tomcat, that is your application server or application layer. And the presentation layer is the end layer, where all the clients or end user can access to your application or can access to your database via internet. That is your mobile or client or desktop or whatever it is. It's a presentation layer. You can access through URL or whatever it is, however you can access it. This is going to be three-tier architecture. This is the industry standard architecture. If you are developing any application, that should be a three-tier architecture. If it is not meeting this three-tier architecture, your design is not to the enterprise level. And along with that, people may go with a two-tier architecture or single-tier architecture. So, but that those are not like enterprise architecture. So, best enterprise architecture is you have to go with a three-tier architecture. So, if I have a three-tier architecture comparison with a standalone and rack, if you see the front end or client or web or mobile or presentation layer, whatever you can call it, like URL or mobile or desktop or client, whatever it is going to be same irrespective of whether it's a standalone or rack. You can see this is standalone, this is going to be standalone, and this is going to be rack concept here in database. This is one instance and one database. This is many instances pointing to one database. This is rack and this is standalone. And then how the application access, the presentation layer is going to be same irrespective of whether standalone or rack. The presentation layer is same, and the middle tier or middleware, Apache server or web server or Tomcat, whatever you can call it, that is your middle tier, and that is also going to be same, like app 1, app 2, app 3, app 1, app 2, app 3, like your application however you design, you can design it here. And from the application, the connection to the database is going to be slightly different. Coming to the standalone and rack, like application 1 connect to instance 1, application 2, application 3, all will connect to instance 1 and connect to database. If this instance goes down, and none of the application is able to access to my database. And whereas here in the rack, application 1 connect to instance 1, application 2 connect to instance 2, application 3 connect to instance 3, and all three instances can communicate to my database. Instance 1 goes down, this app can connect to instance 2 or instance 3, and this instance 3 goes down, this app 3 may connect to instance 1 or instance 2 and still able to access database. That is kind of high availability, or like scale out and scale in, you can do it. There is a performance improvement here, right? You can have n number of instances or you can remove n number of instances. As your business grows, you can add n number of instances. As your business loss, and then you don't want to have a number of instances, you can remove the number of instances, like dynamically scale out and scale in. That is the advantage of having rack. And you can call it as a backend or middle tier or data management tier, anything you can call it here for this tier, right? That is just a quick comparison between the three tier architecture and versus standalone and the rack. And if I go further, on the quiz time here, select all the available architecture in industry: one tier, two tier, three tier, four tier, which are available. You can just mark it here. Going next, connecting to the database, right? As I said, I'll just go back to the I'll just go back to here my database, Oracle database. I have a client installed on my desktop or my laptop. I want to connect to this database here from my desktop or my laptop. I want to connect to this database. This database is here. For example, this is a dev database I am running here. I want to connect to that database. How the connection happens? connecting to the database. So this is my database here. This is the user. I'm trying to connect from my laptop or desktop. I wanted to connect to my database. How I will connect? First of all, I need username and password. Inside this database, I should have my valid username and password. And I should know the host name where my database running. Database is running on this server A or server B or server C. I need this host name or IP address where my database is running, and I need a DB name and what DB is running here, dev database or test database or UAT database or prod database, which database is running, I need that name. And port name, I need a port and which port this database is running, port 1521 or 1522 and 1523, which port it's running, I should know that one, then only I will be able to connect. And protocol, on which protocol my database is listening, either TCP or UDP or RDP or RDS, whatever protocol, right? I should know that name first. Ideally, we use TCP and UDP in industry, right? So if I know all this, I can easily connect to this database. So what I will do, I will put all these entries into one single file, that is tnsname.vara. Like see my SID or dev database or test database or prod database or UAT database, whatever name you can give here, whatever database running, you can give name here, and you can put a protocol TCP or UDP, and put a host name. Host name is nothing but that server name or IP address. You can put anything, whatever it is, server name or the IP address you can put here. Port, and which port is listening, 1521 or 1522, you put that port name, and the database name, that is your service name, and you can put like devdb or testdb or uat, whatever the database name is equivalent to your service name. If there is a difference, you can put whatever the service name you set inside your database, you put that, and using this particular alias string, you can connect to your database. And then you can, once you connect to your database, you can query anything, you can do select dml ddl, whatever query you can run it, that will directly run on your database. This user, that is me, connected to database, that connection is called session. This user is connected to database, that is called session. Or if any other user connect to that database, that is session belongs to that user. And the moment I connect to this database, there is a one server process is assigned to me, and the connection between the server process and user process is called a connection. So you don't worry about this connection and session, I will explain in a while in detail. Okay, so if I can quickly go to lab here, and this is my TNS admin. Like you can see, this is our Oracle home, and this is network admin. That is going to be your TNS admin. And if you go inside that, you can see I did the cat of that cat. If you do the cat of this TNS names that file inside that, and you will see cat db, prod db, whatever database running, you can put it there, and you can see host name here, and you can see this port number and the service name. So everything you can define it here. And how you can check the your database name, you can see ps-ef grep smon or vara, you can see right devdb, and this is what you kept it here, right, devdb. Like see devdb, and host name and protocol and the port and the service name, and you can run this query, and you will see connection. You can, how you can connect using SQL plus or Toad or SQL developer, whatever way you can connect. And you can check all this we'll see it once we progress. We'll see all this demonstration in a live. This is a quick example I showed you here. And going to the next, listener.vara is nothing but this is again kind of a network configuration file where you can define all your database entries, and whatever the end user connection will connect to your listener, and it will establish the connection to the database. See, suppose if I explain about listener files, this is user session, that is I am trying to connect to my database, that is devdb, as you see it in, as you seen this here, right? This is devdb is running here. I want to connect to that devdb. I will send a request to this user. How I'll send the request, I will again I will give all these details. I'll go back, I'll give all these details, or I'll just give this alias name. This alias name is nothing but it includes everything, right? And all these entries, it will be kept under this alias name, right? So I will just give my session, I'll start, and I'll give that all the details. This listener will take my request, and it will connect to database, and it will validate my username and password, and I'll check whether I'm authorized user. And the moment it verifies if I am authorized user, and it will come back and it will acknowledge my connection. Okay, you are authorized user, you can directly connect to database. Then for me, one server process will be started. One user connected, one server process is started, and if other user start, and one more server process will start, and the third user comes and third server process will come. starts, and all the server process will communicate to database, and whatever query we fire, that query will goes to server process, and server process will runs on behalf of us, and it will communicate with database, and it will run that query, and it will get the result, and that server process will give back our result. So if n number of user connected, n number of server process will started. And what is the role of listener? Listener role is just to take our connection and validate our connection. If I am authorized user, it will just establish the connection to the database by launching the server process, and then this listener will goes off, and this listener is no more comes into picture. This listener will come into picture only for the connection time. If you see here, step 1, the request will comes, and listener will take that request, and it will start our dedicated server process, or the shared server process. There are two server process, I can say, dedicated and shared. Based upon your configuration setting, the if it's dedicated, it will start the dedicated server process. If it is shared, it will start the shared server process, and this listener will go off, and then I can directly communicate to that server process, and I can execute any query I wanted to run. And then how this listener works, like this listener, you can see a listener, again alias name, I can put all these details, protocol and the host and the port and which protocol it is running. You have to keep all these entries, and you have to start your listener. If I quickly go to the TNS admin, and I can show you that I am at my TNS admin location. If I do lsfnltr, and this is our listener file. If I do cat of listener dot vara, you can see, right, listener devdb. You can give any alias name here, and then you can see this is the host name, and this is the port, and this is the protocol. And then if you do ps-ef grep tns, nothing is running. So if I do just simply select this one, lsnrctl start, I can paste this listener, and this listener will get start. You can see listener is started. Command completed successfully. If I see lsnrctl status, right, this listener is running. So this once this listener is running, then end user is able to connect. If this listener goes down, none of the users are able to connect to my database. That is, very very important. If the listeners are down, none of the users are able to connect to database, because listener is the one will take incoming connection and establish the connection to the database. If the listener goes down, and none of the users are able to connect to your database, so make sure your listener should be up and running 24/7, and your database also should be up and running 24/7. This is one of our daily day-to-day activity. You have to make sure your listeners is up and running. Again, how you can create this listener.ora using same method: network manager, netmgr, netka, network configuration assistant, or OEM, Oracle Enterprise Linux, or manually you can create a VI editor and put all these entries. Right. So I'll just go further. Again, as I said, dedicated server or shared server process. These are the two connection methods. The moment user sends a connection, listener will take that request, and it will start the dedicated server process, and the listener will goes off. Then this user will directly communicate via that dedicated server process. This user will directly communicate to database via this dedicated server process. That is dedicated server process. If your database is a shared server process, like the user process comes, and the listener will take that request, and the shared server process will launch dispatcher. Here directly dedicated server process will be started for each user. Here, instead of shared server process, one dispatcher will be started. That is a lightweight process. If one shared server process is defined with 100 dispatchers, like this single shared server process will take 100 connections, 100 incoming connections, and it will launch 100 dispatchers, and this user directly communicate with the dispatchers, and then internally this dispatcher will talk to my database, and whatever query I execute via dispatcher, it will go to database, and whatever result will comes, and it will via this dispatcher, it will comes to that user. As I said, one single shared server process, if I define 100 connections, all 100 users will be managed by this single shared server process. And then, but whereas this single shared server process will internally span 100 dispatchers. Those 100 dispatchers will be connected to 100 users. If there is a 101 user comes, there's a one more shared server process will starts, and that second shared server process will be able to manage next 100 incoming users. like that. You have to limit dispatch, like shared server process. You have to define how many users one shared server process can manage, right? So that can be defined at the time of your database creation. And if the single shared server process is able to manage 100 users, all the 100 whatever queries or 100 requests whatever user sends, all will go under request queue, and based upon the priority and based upon the precision, your shared server process will send it to database, and whatever the result will get it, and again that all the result will be in response queue. Again, based upon the priority and precision, this shared server process will decide which one to send the result first. Like 100 users sends 100 queries at a time, all 100 queries will go under like request queue, and this shared server process will decide based upon the priority and precision. It will check all those, and it will send one by one to the database. And once the results will be back, all the result will be kept under response queue, and again based upon the precision and priority, all the result will be displayed back to that 100 users. So that is a quick introduction about dedicated server and shared server process. And going further, can I have more than one listener for each database? Can I have more than one TNS names for each database? Just guess your answers here. We'll come back with the answers. Okay, as we said many things about in the beginning of our class, we demonstrated about what this human chronology with our database, right? Like memory and this pair of hands, like help for writing, like memory and background processes and storage. These are the three typical major components comes into picture when you are dealing with your database, right? When you are trying to understand the architecture. So if you see this entire architecture here, this is instance. This blue screen, you can see instance is nothing but a memory. You can see SGA memory plus the background process. These are the background processes, and at the back end it is your database is nothing but actual physical storage, where you store your database, where you store your data, right? Actual end user data. Typically I'll explain this memory. You don't worry about this all concept. We'll explain all this. Like user process, I'll send a request. This listener will take that connection, and it will validate if I am authorized user or not. After validate, it will send back acknowledgement. Okay, you are a valid user. There's a dedicated server process started for you, or shared server process started for you. You can directly communicate with that. So my connection will be established to the this shared server process in PGA. So then that server process, right? Whether it's a dedicated or shared server process, based upon the installation type, all query, whatever query I fire, all will communicate with my database instance. Via database instance, all the request or the data will go to the data file, and if I'm reading the data will from the data will come back to the memory, and from the memory it will go to the shared server, and it will display it back to the user. Like this is a simple connection method and architecture how it works. And this is about user process, that is end user process. This is listener to handle the incoming connections. And server process, the moment one user comes, one server process is started, and that is under PGA, that is program global area. So each user will be having his own program global area. And second user comes, and second server process comes, and he has his own PGA, that is again kind of memory. And then those server process will communicate with my instance, and that instance will be having memory, that is SGA, shared global area, and background process, that is like BG process. Like if I have a 10 user, all 10 user can communicate to SGA. SGA is a system global area or shared global area. Shared global area means all 10 user can use the same SGA, but all 10 user has their own PGA, program global area. PGA is private to all 10 user, whereas SGA is shared. It's a common to all 10 users. Okay, so then this SGA has internal component like shared pool, Java pool, stream pool, large pool, and DB buffer cache and read log. And again, coming to the background processes, checkpointer, smon, pmon, dbrater, logwriter, reco, and archiver. And if you see here, database coming to the backend storage, I have a control file, data file, and online read log file, and archive read log files. And and then this server process will pull the data from data file and keep it into the DB buffer cache. And this DB writer, whatever data or whatever the uncommitted data and my buffer cache, all the buffer cache will be written to data file with the help of DB writer. And whatever the transactions are returned to DB buffer cache, there's a change vector. The transaction log will be written to read logs, and this log writer helps writing that redo log buffer cache to my redo logs. And I have two redo logs here, redo log 1 and redo log 2, each of 1 MB. I can say 1 MB. The moment this 1 MB is full, and this archiver will do the log switch, and this log writer start writing into log 2, and whatever the content of log 1 will be backed up to archive log. And again, once this redo log will full, and this archiver will do the log switch again, and this log writer start writing into the log 1. It will overwrite whatever existing, it will overwrite and start writing into log 1, and whatever the content of log 2 will again backed up to archive logs. And this is a typical architecture how it works. We will explain in a short minute each and every component in detail, right? If you understand this entire process, if you see this gray line here, this listener and this pmon, what is the connection between this pmon and listener? How this listener knows what database I have to listen, right? This pmon will help dynamically register my listener with my database, right? Listener A is running here, database A is running here. This pmon will smart enough to understand, smart enough to register my database with the listener. So this is a database A, it has to register with listener A, because I'll be having listener A, listener B, listener C. I'll be having database A, database B, and database C, and each pmons in database A is able to responsible register this database with listener A, and the pmon of database B is able to register with the listener B, and pmon of database C is able to register database with the listener C. Like, basically without pmon you cannot do the dynamic registration of your listener and database. Okay, just we'll go each and every component in detail. Just I will start with the memory component, that is like PGA also one of the memory component. That's a private global area, is individual to our each user session, end user session. SGA is a shared memory area, that is shared across all the user session. If you see here, program global area PGA for this user A, that is server process, and server process 2. Server process, when it comes into picture, the moment one connection comes, one server process, second connection comes, second server process will be started, and all the users will communicate with the server process. And each user session or the server session will be having their own program global area, that is program global area are private to that user, and it has stack space and user global area. User global area is nothing but you can store your variables, right? You can, whenever you open your cursor and whenever you define your variable in your PL SQL program or SQL program, you can define certain variables. All the variables will be defined under user global area. And stack pack is nothing but keeping your cursors and cursor area, and when you open your cursor and when you close your cursor, all the memory component, memory stack will be kept under your stack areas. This is going to be same for all the PGAs. If I have user 1 and it has a stack space and user global area, it is private to that user, and I have user 2 here, and again it has its own PGA, and again it has my stack space and user global area. Stack space, as I said, it's a memory component which is holding our cursor pointers and vectors. When you open your cursor, all the memory stack will be allocated from the stack space, and user global area is dedicated to that session. Whenever you define variables, like as usually you define in your C program or C hash and Java and .NET, right? When you define your variable, all the variable will be defined under user global area, and that will be dedicated to that particular user as long as that session is established. And all these users are able to communicate with my SGA, because SGA is a system global area or shared global area. It's a only one memory can be shared with the n number of users. And as I said, like each SGA has its own component, like shared pool, database buffer cache, redo log buffer cache, large pool, and Java pool, and stream pool. Shared pool is nothing but it's one of the critical memory component, which has internally library cache and data dictionary cache. Library cache is nothing but whenever user do any DML, DDL, and select query, whatever query you'll do, that query will go under parsing. That the past representation of query will be kept under my library cache, and the data dictionary cache will be actually holding data dictionary metadata. And then next time, when in second time any user fires the same query, it will directly check into the SQL area. If that query is already ran in my past time, if that is ran, it will take that past representation of SQL from the library cache and it will execute it. If the query is a brand new, it is not ran in my past time, then that will go for the all this parse, fetch, and executing phase. That is, I will explain in a while how it works. Once that is done, and then it will verify in dictionary cache whether that object is available or not. If it is available, and then it will give the data, and if it is not available, then it will give the error message to the users, and table or view or not exist. Okay, just remember this shared pool is having two component, that is the library cache and data dictionary cache. Library cache will be having my past representation of SQL. For example, if somebody queries select star from employee, that past representation of that query will be kept under library cache. And what is the dictionary cache? Dictionary cache will be having all the dictionary views or dictionary metadata like tables, views, indexes, synonyms, all will be kept under the metadata will be kept under that dictionary cache. Right, that is about stateful. And db buffer cache is nothing but it is a memory component where whenever any query is updated, or any select query or any update query, insert query, whatever query end user do, all the data will be written to my buffer cache. And then from buffer cache it will go to the data files. If I go back here, whatever end user query, end user update, insert, whatever the blocks will be written to database buffer cache, and from the buffer cache db writer will pick up that blocks and write it to my data files. Okay, that is about db buffer cache. And then coming to the redo logs, each and every transactions, whatever the dml or ddl, insert, update, delete, or select, whatever query happens, all the blocks will be returned to db buffer cache, and respective transaction logs or log vector will be written to redo logs. And this redo log writer will write whatever content of redo log to my online redo log files. That is about read logs. And coming to large pool is nothing but it is a special memory component, very very helpful when you do the large IO operations, especially when you do the rman backups and recoveries. All the memory will be allocated from this large pool, because when you do rman backups and restore, there will be large IO operations, and that will be perform like that will impact your database performance. To avoid that, the memory will be allocated from the large pool, and the large pool will manage this all the IO operations. And the Java pool is nothing but when your database is using the Java applications or Java virtual machine JVM, and your end user business logic will be having your application related to Java component, or your database having the component which are related to, which are responsible for handling your Java JRE and JDK, or the JVM Java virtual machines. Then the memory will be allocated from the Java pool. So this Java pool basically helps if your application is Java related or Apache Tomcat related, and any object related to any component inside database related to your Java, that will be managed by your Java pool. A stream pool is nothing but it is basically responsible for handling your Oracle streams. Oracle streams is the kind of taking a backup of your tables. If you're taking a backup of your tables regularly, like your DR setup, if you want to have a particular critical tables constantly backed up to a certain objects or certain area, then there's a stream concept. Oracle stream concept will comes into picture. So this stream pool helpful for managing Oracle streams. And this database buffer cache has some different concept. You can see keep buffer pool, recycle buffer pool, and nk buffer pool. Like this buffer pool, this db blocks will be default 8k, and if you want to have a more like different buffer pool like 8k, more than 8k, you can go with the nk buffer, that is higher than your usual buffer blocks, like db block size is 8k. So if you don't want to use that 8k block, you want to use a higher block size, you can go with nk buffer cache. Or the recycle pool name itself says whatever whatever the block you place inside your recycle buffer pool immediately will be removed, it will be recycled. And keep buffer pool, as name it says, if you keep block inside this keep buffer full, it will be kept forever until you delete it. It will be kept forever. It's a different kinds of buffer fulls, right? Again, I will show you this. Okay, just quickly run this one just to uh, show you, right? I'll just connect to my database. It's connected to idle instance. Let me set the environment dev db. Okay, connected to database. If I run this query here, okay, not copied. Let me copy it and paste it here. You can see SGA, right? Total SGA 1.5 GB, 1.5 MB, sorry, 1576 MB, that is 1.5 GB. That is my total SGA. If I go back here, so this is my SGA. So these all are SGA. This 1.5 GB, whatever you are seeing here, 1.5 GB, that will be distributed to all of these memory component. So how it is distributed, that we'll see it once we go into the lab session. Okay, going further, if you are understand about how this SGA and each of these components said full, again it has a two component, library cache, data dictionary cache. Library cache is having past representation of SQL, and data dictionary cache will be having your data dictionary metadata, like your index, objects and views, tables, all those will be there. Buffer cache, like db blocks will be returned to your buffer cache. End user is insert, update, delete, it will go into and update into buffer cache. If the end user session is select employee table, and whatever the data available in the employee table in data file, it will go and your server process will go and fetch and it will keep into buffer cache, and from the buffer cache it will given back to the user session. If it is a select, it will read the data from buffer cache and write into it will read the data from buffer data files and will keep into your buffer cache, and from the buffer cache it will given back to the users. If it is insert, update, delete, all those sessions will write data directly into your buffer cache. From the buffer cache, db writer will write that change data to your data files, right? That is about buffer cache. Redo logs, whatever the operation you do here, insert, update, delete, all those will be logged here in the redo log, like transactions or change log, and redo vector will be written here, because when you do the instance recovery and instance crash happens, we will read this redo log and we'll redo that transactions. If some insert up happened here, and data will be returned to my buffer cache, and the transaction log or vector will be returned to transaction vector will be redo vector will be returned to redo buffer, and then from there it will return to my redo logs. And if this instance crashes, we will read those redo logs and we'll replay those SQLs and we'll go into the point in time recovery. That is about redo logs, redo log, buffer cache, and stream full for the stream processes. Java full, if you are using a Java application, Java objects are running, so you use the Java pool. And large pool for the larger IO activities like armament backups and recoveries. The large pool will be used. And the stack pack is for like opening cursor and keeping cursor and allocating memory. Everything will be assigned from the stack space. And user global area, whenever you are defining your variables, constant, and all those will be assigned here. And this PGA is private to that each user session, and this user session also has PGA that is private to that user session. Again, server process will be assigned the moment your connection is established to database. Again, the server process is a shared server process or dedicated server process, depends upon the configuration. So that's about the memory component. And the next question is memory region that contains said SQLs and library cache. Which one is that? You just guess here. And then going to the background process, see, I removed all the memory component from the SGA, because we are done with the SGA component, SGA explanation. We'll just go to background process. Background process are like DB writer, checkpoint, log writer, smon, pmon, and recoverer. And there's a ASM particular background processes. We have a separate class on ASM. We will explain about the ASM related background processes in that class. Now we will go with whatever the mandatory background processes like liberator, checkpoint, log writer, smon, pmon, and recoverer. These are like background processes, and this archiver, ASMMB, RBL, these are like optional. This ASME and RBL comes into picture when you have ASM. So we'll explain when we deal with the ASM. Okay, coming to the DB writer, as I already explained, DB writer is responsible for writing blocks from the DB buffer cache to your redo log. I'll just go back to the previous slide. Then where is that? Okay, give me a second. Give me a second. I'll go back. Okay, here it is, right? So DB writer, whatever the changed blocks in my buffer cache will be returned to my data files. And log writer, whatever the redo vectors is written to redo log buffer cache, that will be returned to online redo logs. And this smon, before, if you understand about DB writer and log writer, just writing our buffer cache to DB blocks or the data files, and log writer from redo log buffer to redo logs. And coming to the pmon, I already explained what is the use of pmon, like registering database with the listener, dynamic registration, pmon. And the other task what pmon will do, whenever user session fails and like goes to idle session or the network disconnection happens, it will clean up that user sessions. And the smon, when you have like instance crash or instance recovery, this server will go down unexpectedly with the power outage or power server crash happens. When you start your database next time, this smon will do the instance recovery by reading your redo logs. It will read the redo logs, and if there are any committed data, it will go for roll forward. If there is uncommitted data, it will go for roll back. So that is a uh, you know uh, the smon will do, that's the activity smon will carry out regularly. Checkpoint is nothing but if the checkpoint regularly, checkpoint is a process will update the control file header and data file header. It'll basically keeps the consistency at my database. So somebody do the commit or some database goes down, somebody do the shutdown, or somebody something happens, this checkpoint will regularly keep updating control file header and data file header to keep my database in consistent state. What it will update, both control file and header, it will update scn, system change number, whenever user do commit and whenever database do shutdown. There are so many scn, like scn number will be keep generating regularly, frequently, do a lot of commits and a lot of updates, and regularly there is a scn number, system change number will be keep generating exponentially. And those the system change number, it will be the checkpoint will be updating on my control file header and data file header to keep my database in consistent state. If this control file will not update into control file and data file, your database will go in inconsistent state, and you will not be able to restore and you recover your database in case of any server crash or instance crash. That is about the checkpoint. And the recoverer comes into picture when you do the distributed transaction means single query, you run it on a multiple databases. Like if I have instance a, instance b, instance c, like multiple instances are running, and if you are running the distributed query across all the instances, and then the recovery will come into picture. Because if there is any failure in that distributed transactions, the remote instances are there's a network drop or network disconnect, and if that remote instance will not send any acknowledgement back to the instance one, so your recovery will clean up those distributed transactions. Only when you are using a very rare distributed transactions, very rare they will use when the distributed transactions, when the remote instances will not be able to, remote database will not be able to send back the acknowledgement, then your recovery will clean up those distributed transactions. As I said, archiver is comes into picture when you have database in archive log mode. This archiver will come into picture. If your database is not in archive log mode, you will not be able to generate archive logs. Your redo log will be overwritten again and again. Archiver process will be helpful for generating my archive logs. Like this redo log writer will be writing into redo log one. When this redo log is full, archiver will generate one archive log. It will take a backup of that, and log writer will start writing into redo log 2. And once this redo log 2 is full, and archiver will generate archive log, whatever backup it will take into archive log, and log writer start writing into redo log 1. Right, so that's about the background processes. DB writer, as I said, writing DB blocks from DB buffer cache to data files, and checkpoint to updating scn number, like system change number, to my control file and data files. And log writer, whatever the redo log buffer, it will write into redo logs. In smon, when system crash happens, smon will responsible for recovering my instances, rolling forward or rolling back. If it is a committed data, it will go for roll forward. If it is uncommitted data, it will go for a roll back. pmon for the instance registration, dynamic registration, and the other task is to clean up any this user session disconnected. It will do the cleanup of that. And recoverer comes into picture when you are having the distributed transactions, and when there's a remote instance or remote database cannot be able to send back the response, then this recoverer will clean up those undoubted transactions. And then this recover archive log is like generating your archive log from your redo logs, and this will explain in our asm class. And just to show you all those background processes, I'll just run this particular query. I'll go back to my database, exit, and I'll clean this. And if I do psf and gap, okay, let me see what is okay. Hyphen is the one. I need to give this one here. See, this is my development database. I have my pmon here, and I have my log writer, I have my db writer, and I have my smon here, I have recoverer here, and I have archive 1, archive 2, archive 3, and what else, checkpoint. You can see checkpoint process. All these are like mandatory. Along with that, so many m1 mnl, these are like we'll explain after down the line, like what is the diag, dbrm, this is vktm. We'll explain all those once we go into advanced topics. So right now these are like mandatory: db writer, checkpoint, log writer, smon, and pmon. Record without these you cannot run your database. And these are like optional: archive, smb, like these are not mandatory, right? Like, let's go to the next topic. Okay, what pmon process is responsible for? Just guess your answer here. Let's go further. Okay, coming to the third topic, again I'll go back to the original topic. See, we explained about memory concept, sga, pga, what are sga component, what are pga component. We explained about background processes like smon, pmon, db log writer, archiver, recoverer. What are the mandatory processes? Some are like not mandatory. Those are like we'll explain in our advanced topics. And now we'll go deal with into what are the storage files, what are the database files. So this is very important. You have to understand what are database files, right? So these are like overview of our storage architecture, or what are database files. You can see control file, data file, online redo logs, archive logs, backup files, parameter files, password files, and temp files, and alert log and trace files, right? If I show you here, control file, I already told you, whenever checkpoint happens, it will update control file header and data file header. What is there inside my control file? Control file is the heart of my database, I can say, because this is the one which will define my, and which will hold my entire database structure here. Without this control file, you cannot start your database, you cannot recover your database. Control file is kind of a heart of my database, which will be having all the timestamps, when my database started, when my database shut down, and what is the state of my database, how sorry, sorry for that. Okay, this is just the heart of my database, right? It will be having my, when my database created, what is my database structure, and what are my data file, what are my redo log files, and how my database looks, and all the timestamp, all the SCN information, everything will be there in my control file. You are, that is why you have to have a multiplex control file. It means you have to have a duplicate of your control file 1, control file 2, control file 3. You have to have a duplicate of control file, because in case of if you lose one control file, you can start your database with a control file 2 and 3. And data file is, as name says, it is actual data file which holds end user or application data or end data. Whatever transaction you do, all the data will reside on my data files. Redo log files, as I said, redo log file are like, it's a transaction change vectors. Whatever the transaction each and every end user do, all the transactions or transactions logs or redo vectors will be written to my redo logs. And out of this redo logs, archive log will be generated, backing up sorry, if you backup redo log 1, archive log 1 will be generated. If you backup redo log 2, archive log 2 will be generated. And again, backup redo log 1, archive log 3, archive log 3. The backup of this redo logs is kind of archive logs. These are comes into picture when you do the instance recovery, or when you want to go for point in time recovery. You can read your redo logs, and you can do the point in time recovery. And the backup files are nothing but, as name says, is the backup files. If you have control file backup, it's you can call it as a backup files. If you take a data file backup, you can call it as a backup files. If you can take archive backup, you can call it as a backup files. If you can take a backup of your sp file, p file, you can keep it as a backup file. No, it's just a name says you can backing up all the files and calling it as a backup files. You can backup using rman, you can backup using export, and you can backup using sql loader, whatever you can do the backup. Parameter file is nothing but it is the initialization file. And the moment you start your database, first file is read, it's your parameter file. Like parameter file is nothing but it is like, I can say it's the key value pair. There's a key and particular value for that. Like key is nothing but like db name is a key, and my name is dev database or test database or UAD database. Like key and value, I can say that control file, and I have a control file location. Control file is the key and control file location is a value. And I have SGA and 1.5 GB. SGA is a key and 1.5 GB is a value. The control file is a key value pair. And parameter file, you can have it as a SP file or P file. SP file is a binary file and P file is a human readable file. The moment you start the database, the first file is read, it's your P file. If you are not able to find the P file, your database will not start. And the password file is for admin user to log into database remotely to do the maintenance activities or administrative activities. You can define your password file using some utilities. I will explain about that. This password file will be having your admin user name and password. And temp files are nothing but, as name says, temp files will be used for sorting operations or reversal operations, and like ascending and descending, all the sorting operation will be done in temp files. These are like temporary files. And alert log and trace file. Alert log is nothing but whatever activity you do at your database, all will be logged into your alert log, and you can keep one of the best the DBA task, or the best practice is you have to always keep monitoring your alert log. If you see any messages, any errors, any warnings in your alert log, you have to take care of appropriate action. So alert log is the one which will tell you how your database is functioning. If your database is functioning healthy, you don't see any WARA errors or warnings in the alert log. If you see any WARA errors or warnings in the alert log, you have to take appropriate action and keep your database healthy. And trace files are nothing but whatever you see alert message or warnings in the alert log, the particular trace bunch of information will be returned to some certain files. Those are trace files. If the alert log will show only the error message, and then it indicate the particular trace files. If you read the trace file, you will see more information on that. So that's about the storage architecture. How what are the files you can see at your database side. So if you see DBA data files and LSN LTR, you can see all the files. We will see all this once we go into the lab hands-on experiment. So while going further, what are the mandatory database files for your database to operate? Like as I said, I already explained, and just guess what are required for your database to operate functionally. And if that is about all your data files, and as I said, this is data file is the actual files which holds our all the end user data, transaction data, all the business application data, whatever data you feed, everything will be written to my data files. So how that inside my data file data is written, that we can see it in a physical and logical database structure. How you can see your database in physical and logical structure. Physical structure is nothing but at storage level you will be having your data files. You can see ls-ltr, you will see all the data files. So if I can quickly show that one, cd, give me a second, I'll just show you the cd u01 app oracle vara data, and I have my database name here, devdb. And if I go inside, you can see, right, control file, example, and redo logs, and sp file, sysocs, system, temp, undo, users, like .dbf, right? If I do lsnr ltr .dbf, right, all the data file will be ending with .dbf. System, sysocs, undo, system, example, user, temp, all are like these are your data files. So how you all the combination of your data files is nothing but your database as physically, right? So these data files may reside on your SAN or NAS, Exadata or file system or NFS, ASM and RAW, wherever it is. In my case, this is my Linux server I am having locally on this mount point, right? PWD. This is my OS file system. You can see this is file system. I have my database within within my server itself. So you can have your database inside SAN, NAS, Exadata. Remotely you can have anywhere. And then sum of all those data files is nothing but your database. And if you see logically at the database side how it works, your database is divided or combination of your table space. And table space is associated with your data files. And if you can see, if I go back, your sysocs data file is belongs to sysocs table space. Undo data file is belongs to undo tablespace. System data file is belongs to system tablespace. Example data file belongs to example data tablespace. User data file belongs to user tablespace. Temp data file belongs to temp tablespace. Right. So that is how your tablespace is associated with your data file. And sum of all my tablespace is nothing but sum of database size. And internally this table space is divided into segments, and segments are internally divided into extent, and extents are basically mapped to my Oracle data blocks, that is 8k. And this Oracle data blocks 8k is mapped to my OS blocks at my OS server level, right? So like combination of my Oracle data blocks is extent, and combination of extent makes segment, combination of segment makes table space, and sum of all the table space is become my database. And this table space is associated to data files. As I said, I'll go back to my lab here. I have 1 2 3 4 5 6 data files, and I have 6 table space. And I have one more one temp data file. I may have one more user data file. I may have two more example data file. I may have like three more undo data files, right? So it means if you see here, one table space can have multiple data files, right? So as you want to have two more data file, you can add it to the one particular table space. Sorry. Okay, as I said, like your disk blocks, right? Your OS blocks, you group together your OS blocks and make your Oracle data block, and group of your Oracle data blocks makes your extent, and group of extent will make your segment, right? If somebody say what is segment, segment is nothing but it's logical unit of my database, which is combination of my extent. If somebody say what is extent, is again it's logical unit, which is combination of my Oracle data blocks, that is typically 8k. And what is data blocks? Data blocks are nothing but it's a smallest unit of my database, and then those are associated to OS blocks. Okay, coming to the quiz time. Size of database is determined using sum of table space or data files or segments. Just guess your answer, what are applicable. Next question, what is the smallest unit of my Oracle database? What are the building blocks of my data files? What is the smallest unit of my Oracle database? You can just guess your answer here. Going to the next. Tablespace, as I said, tablespace are associated to my data files. So you can see tablespace 1 here, tablespace 2 here, and then tablespace 1 will might be having data file 1, data file 2, because initially I have tablespace 1 and I'll assign one data file, and then later point I can have one more data file, and later point I can have one more data file, right? So tablespace can have n number of data files, and and then each data files will be associated with extents, and then each extent will be associated inside 8k blocks, right? You can see 1 2 3 4 5 6 7 8, this 8k together I make one extent, and in the data file 2 I have this 12 8k blocks. All these 12 blocks together I can make one extent, like 64k and 96k, and these two extend together I can make one segment. So again I'll go back here. My OS blocks are fixed. It again depends, varies from OS to OS. Linux has a different OS block, and your AX, Ubuntu, and each OS has its own block size, and that is the OS part. You don't worry about that. We comes into picture only data blocks. Data blocks are nothing but my actual Oracle data blocks, that is 8k in size. So this is fixed. Your data block size are fixed, that is always 8K. You cannot have a different OS blocks. Sorry for that. Okay, so what happened, like your OS blocks are different to each OS flavors, and your data blocks are fixed for your entire lifetime of your database. If you define 8K blocks, all the blocks at your database are 8K. You cannot have a different block size in your database. So these are like 8K blocks. But whereas extent, what I said, extent is nothing but combination of my blocks. So I can group only 4 blocks and I make one extent. I can group around 8 blocks, I can make one extent. I can group 10 blocks and I can make one extent. Extent might be in various size, but data blocks are fixed 8K size. And whereas segment, the combination of my extent. Again, segment, I can make like 3 segment together, I can make one, sorry, 3 extent together, I can make one segment, or 4 extent together, I can make one segment. This segment and extent size may vary based upon the how much you can combination, right? That Oracle decides internally, but data blocks are fixed in 8K size. So that is what I am wanted to explain here. You can see extent, these are like 64K extent, like 8K 8K 8K, like I 8K blocks, 8 blocks I can combine, I can make one extent. And here 8K blocks, 12 blocks combined together, I can make 96 extent. These are two very different size in extent, and combining these two together, I can make one segment. And then this segment will be resides in my table space, right? So then entire table space group together, I can make my database size. And coming to the big file table space is nothing but you can have as I said, like very beginning I explained you about can I have a data file size as a limit, can I have my table space size as the limit. Yeah, you there is a limit for each and every data files. You cannot grow more than 32 GB. So if you want to grow more than 32 GB, so you have to go for the big file, data file. You can define like 100 GB data file, and 200 GB data file, and 300 GB data file. So if you mention while creating a table space, if you mention big file data file, then you can have more than 32 GB. But whereas typically in each data file, 32 GB is a limit. You cannot grow more than 32 GB of each your data files. For example, table space 1, I can have one data file of 32 GB, another data file of 32 GB, and data file 3 of 32 GB, because you cannot go more than 32 GB. And table space 2, if you create this table space 2 as a big file data file, you can grow data file as long as you can, like 100 GB, 200 GB, 300 GB. You can define whatever size you want. You can see only one data file allowed 128 terabyte. That is if you define big file table space. We can practically see when we are into a practical lab exercise, we'll define this table space and we'll define this data files and we'll define this big file data files. Everything we can see it here. So I hope this is very informative. If you understand that, I'll proceed further. Table space, right? I explained about table space like syssoc, system, undo, temp, user, example. All are like these are the table space associated to respective data files. So what are critical for my database, right? If we talk about the critical table space, like system and syssoc, these are the two table spaces are critical to my database, and associated data file like system data file and syssoc data files are critical to my database. If you lose this system and syssoc, you cannot start your database, you cannot recover your database, you have to rebuild your database. And undo, temp, user, examples, if you lose your these table space or the data files associated to this table space, these are non-critical. You can rebuild them, you can recover them. Like sys and system table space are mandatory table space. Why those are mandatory table space? Because those are the one which are having your metadata information, your database information. And system table space is the one will be having your dictionary views, like v dollar or whatever the core metadata dictionary will be found on your system table space. Syssocs will be having your enterprise manager repository, AWR repository, all the repository information you can see it in your syssocs. That is why system and syssocs are very special. and critical to my database. If you lose these two tablespace, you cannot recover your data file. You cannot recover your database. You have to rebuild your database. And system and sysdocs, temporary are not recommended. Like, if you want to keep, like, system and sysdocs are, like, as I said, these are the critical and core functionality of my database. You are not supposed to keep any of the application data here, any of the user data here. For that, you keep data in user tablespace, or you can create a one more tablespace called application, or if you're running a EBS application, you can create a tablespace called EBS and keep your application data into that particular tablespace. You should not touch your system and sysdocs tablespace. Okay, going next, quiz time. What are the critical data files of my database? Users, system, temp, sysdocs. Just guess your answer here. Okay, so I think that's it for the architecture point. And then next topic will be our ASM architecture. We will take it in the next class. Thank you, guys.